Today we are going to go through both 12.4 and 12.5, both very short. I need you to start by opening your Springboard book to page 204 because we're going to be looking at this chart that's in your book. So you definitely need to be looking at it to go over it here. So again, we're covering 12.4 and 12.5. Make sure you look at your syllabus and pay attention to which numbers are assigned for the homework tonight. I'm also going to be very specific about what's required for your homework. So please make sure that you follow my directions when you go to do that. So in 12.4, we are looking at the discriminant, which is something that we learned back in Activity 9, and now we're going to be using it. We're going to be kind of reviewing what we did originally in Activity 9, but then taking it to the next level in that we are going to see how the discriminant applies to the x-intercepts rather than just the nature of the solutions, which we already talked about. Then after we look at that, we're also going to be graphing some quadratics using our graphing calculator. So that really is review, except that we're kind of using it in a different situation. But the functions we're going to do on the graphing calculator are not new. Everything there is review. So on page 204, you have a very lovely chart that looks like what you see here on the screen, and it talks about the discriminant, its value. It also talks about the solutions and the x-intercepts, and then it gives you a sample graph. So first of all, remember that the discriminant of the function is b squared minus 4ac. So you can see that right here. So when it says b squared minus 4ac greater than 0, you can even just write above that positive, because that's what greater than 0 means. So we learned in lesson 9.3 that if the discriminant is positive, that means that there are two real solutions. This also means that there are going to be two x-intercepts. So if the discriminant is positive, that means that your parabola is going to cross the axis twice. So here's an example, a sample graph. Remember that it could also open down and touch twice to have two x-intercepts. Now, it's important that you know these qualifications, and really, if I were you, I would draw a line connecting a perfect square to roots are rational. I would also right next to it, x-intercepts are rational, because that's what you'll be asked to do, is to classify the solutions as well as the x-intercepts. So if it's positive in a perfect square, then that means you have two real rational solutions, which means you have two real rational x-intercepts. Connect not a perfect square to roots are irrational. So if it's a positive discriminant that's not a perfect square, you have two real irrational solutions, which means you have two real irrational x-intercepts, meaning it's not going to come out evenly. Then if the discriminant is actually equal to 0, then that means there's one real rational solution. We call that a double root, which means there's one, and then you need to write real rational x-intercept, because it's important that you know what type. Here's a sample graph. If there's only one x-intercept, that means the x-intercept is at the vertex. Again, it doesn't have to open up. It could open down, but the point is that the vertex is going to be the only x-intercept there. Final situation is when the discriminant is negative. So you can write right underneath here, negative, because that's what less than 0 means. So when your discriminant is negative, that means that you're going to have two complex conjugate solutions, which means you have no real x-intercepts. Now, on my online version, I don't know why, but the graph is incorrect on my online version, but I think that in your book it's fine. No x-intercepts mean that it's completely above the axis, so I think they moved this up one. which is what it should be because it should not touch the axis. Again, it could also mean that it's completely below the axis as well, but it does not touch the x-axis. So this chart you need to have memorized. That's not something that I can do for you. It really shouldn't be hard because you're already supposed to know the parts about the solutions from back in Activity 9. So all we're adding is the x-intercept part. So discriminant negative, no real x-intercepts. Discriminant 0, one real rational x-intercept. Then up here, discriminant positive, perfect square. That means two real rational x-intercepts. Positive but not a perfect square means two real irrational x-intercepts. So the first part of your homework, if we scroll all the way down to the practice, the questions that you're answering are just related to that. So two real rational solutions, how many x-intercepts does it have? Explain all of those things. So the first couple of those are just based on knowing that chart, so 7 through 9. So then the next thing we're going to do is looking at answering 10 and 11 because I only assigned through 11 in this first section since you have another section as well. So these directions say for each equation, find the value of the discriminant and describe the nature of the solutions. Then graph the related function and find the x-intercepts. So on these, again, I want to be very clear about the expectation for what it is you want. So in section 12.4, for number 10 and 11, you need to show work for the discriminant. So you actually need to show me b squared minus 4ac on your paper for both 10 and 11 to show what it is, and then write your answer about the nature of the solution. So is it two real rationals? Is it two real irrationals? Is it one real rational? Is it two complex conjugates? Then you're going to actually graph it. Now, the graph can be done in this section using your graphing calculator. So graph on your TI-83 or 84. You need to list the x-intercepts because it says to find them. I am going to add that you also need to list the vertex because you can't properly graph it if you don't know where the vertex is. So we're going to be finding these the same way we've already found them. This is not new. I'm going to go through one example again with you, but they're the same functions we've been using. So x-intercepts you're going to find by doing second trace, choice 2, the zeros. Vertex you find by second trace, either choice 4 if it's a maximum or choice 3 if the vertex is a minimum. So again, we're going to look at an example here of running through that, but that's what we're looking at here. All right, so we are going to look at, in the CYU section, number 4 right here, x squared plus 3x plus 1 equals 0. And again, the directions are the same as 10 and 11 in your homework. Find the discriminant, describe the nature of the solutions, then graph the related function and find the x-intercepts. So this is, again, number 4 on your CYUs on page 205. So we're starting out with x squared plus 3x plus 1 equals 0. So first thing it asks you to do is find the discriminant. So the discriminant is found by using b squared minus 4ac. So 3 squared minus 4 times a, which is 1, times c, which is also 1. So 3 squared is 9 minus 4, which gives me 5. So this is the value of the discriminant. I've done that. Now it says I need to describe the nature of the solutions. This is a positive discriminant. It is not a perfect square. So that means these are two real irrational solutions. So that's how I describe the solutions, again, just using my chart that we went over. Then I need to graph the function on my graphing calculator, list the x-intercepts and the vertex, and then I'm going to, I forgot to write, actually draw the graph labeling those points. So here's my instructions. Here is my work. So in my graphing calculator, pull that up, and I'm going to go to my y equals screen, and I'm going to type in my function. So x squared plus 3x plus 1. I'm not sure what window I have right now, so I'm going to zoom 6 to go to a standard window. Okay, so I can see my parabola fairly well here. So again, I need to find my exact values for my x-intercept as well as for my vertex. It does not matter which ones you do first. I'll do the vertex first. So second trace. In this case, the vertex is a minimum since it opens up. So choice 3, minimum. Left bound for minimum means move your blinky so that we're to the left of the bottom. Press enter. Then right bound means to move to the right of that valley. Then guess, press enter a third time, and then it spits out for you minimum. And we, of course, round here. Negative 1.5 for the x, negative 1.25 for the y. So I go back, and if this were my homework problem, I would be writing vertex, negative 1.5. I already forgot what it was, negative 1.25 for the y. Okay, so I've got that. Now I need to find the x-intercepts and record them. So I find those, second trace, choice 2. So I'm going to find this one first. So left bound means over here. Press enter. Right bound means scooted over here. Press enter. Guess, yes. Press enter a third time. And there is my x-intercept. I'm just going to round to the nearest hundredth. So I'm going to do negative 2.62. So x-intercepts. My first one is negative 2.620. And then I know there's another one because I can see it, and because there should be 2 real irrational x-intercepts as well. So find the other one now, second trace, choice 2 again. But now I'm moving over here to find this one. So left bound here, this is to the left of my x-intercept, so press enter. Now right bound, move to the right of my x-intercept, press enter. Then tell it to guess. And I've got negative 0.38. So, negative 0.380. Again, make sure you're listing these as ordered pairs. So now I just need to actually put it on my graph. So, vertex, negative 1.5, negative 1.25. So here's my vertex. Again, this is not a sketch. You're actually plotting the points. Then negative 2.62. So right here, negative 0.38. Be about right here. And it opens up. Start at the bottom to make sure it's rounded and not pointy. And there we go. So this example shows you exactly what you need to do for 10 and 11 in lesson 12.4. The other ones are just answering the questions based on that chart. So if you need to watch this video again, it's posted on the website. So feel free to watch it again if you need to go over the graphing calculator stuff again. Now we're going to go ahead and move on to lesson 12.5. So if you want to turn the page again, we are on page 206. So I'm going to go over here in my online Springboard book and bring up lesson 12.5. So here we're going to graph quadratic inequalities and determine solutions to them by graphing. All of the work here, just like in 12.4, is in the graphing calculator. So I'm going to require you to write some things down. However, the bulk of your work is really done on your calculator. So you're just going to be recording answers per se for the work that you write down on your paper. So in here, you can see that they tell you how to do this by hand, which is great. If you want to know how to do it by hand, that's helpful, because what if you, for some reason, can't figure out what's wrong with your graphing calculator on the test? It would be good to know how to do it by hand. So if you're asked to graph this or solve it, remember that when we're using inequalities, if it's a plane greater than or a plane less than, you need to make sure that your curve is dotted. You definitely need to know this, because not all graphing calculators will dash or dot it for you. If it has the equals with it, then it should be solid. It should be a filled-in parabola. When you graph your parabola, you can do that the same way that we did in lesson 12.3. So if you want to find the points, you could do that by hand. Opposite of b over 2a, solving, using factoring or quadratic formula. Again, you don't have to do any of these homework problems by hand, but you could if you wanted. The last thing that's different here in this section is that you have to shade. So the best way to know which way to shade if you're doing it by hand is to pick a point. I almost always pick 0, 0 unless it's on the boundary line. You have to pick something that's either completely outside the parabola or completely inside. So I usually pick 0, 0. When you plug it in, if you get a false statement, that means the area that contains 0, 0 should not be shaded. If you get a true statement, it means that the area containing that point should be shaded. So here they got a false statement, so that means don't shade where 0, 0 is. Shade the other area, which would be the outside in this case. So I'm going to go through how to do all this in the graphing calculator, but again, that is how you would do it by hand if you wanted to do it by hand. All right, so let's look at our graphing calculator again. We are going to do the example, try these A part C. So we're going to do this one right here. All right, so in our graphing calculator, we're going to need to put in the negative 3x squared plus 8x plus 3. So we go back to our calculator here, go back to our y equals. And then we're just going to type in negative 3x squared. Oops, I forgot to clear the other stuff. Let's try that again. Negative 3x squared. And then plus 8x plus 3. Now, if for some reason you forget the inequality stuff, you could always graph it just like this and just do the shading by hand, meaning pick a point and plug it in. You're more than welcome to do that. Please make sure that you use the negative sign here and not subtraction key, otherwise it's going to tell you error. So there are 3 different situations for turning this into a less than, which is what we want the symbol to be instead of equal sign. So option number 1, you need to hit your apps key. So there's my apps key. And look, scroll down in your apps and see if you have one that is named. So I'll write this down, apps. And then its name is inequals with a Z. If you have that in your apps list, then scroll down to it and press enter over top of it, and it will start running the app. Now, obviously, I can't show you what that looks like because mine doesn't have it. But if you have that app, then when you're in your y equals screen, when you scroll over to the left on top of the equal sign, I went too far. So when your blinking cursor is right here, if you are running the app, then you're going to see along the bottom here all of your inequality symbols. So you'll see the equals, you'll see greater than, less than, greater than or equal to, less than or equal to. Whichever one is which. So let's just say that greater than is above here. Again, I don't know because I can't see it, but let's just say it was above the window key. If that was greater than, then you would press alpha window to select that. So you need to, if you do have that app, make sure you move your cursor over to the equal sign and go ahead and select the one that is associated with less than. So alpha, and then whichever one of these 5 buttons have the less than symbol above it. So if you have that version, then you can go ahead and just kind of hold tight for a second while I talk about the other versions. So if you had that version, apps, inequals, and then you press alpha, and then top row to select the correct symbol. So if you do not have that, then what you need to do is keep scrolling to the left. So not just to the equal sign, but all the way left so that your cursor is now blinking over here. If you have a color one, it's blinking on the color and this little line. If you don't have color, then it's just blinking on the line. And what you need to do is press enter. So obviously you can change the color here, but that's not what we're doing. Some of you, when you press enter, you get this menu that looks just like mine. Some of you get a menu that has an extra button where you can actually select the less than, greater than symbol. So again, if that's you, then just scroll down to the one that selects the symbol and choose the less than, and then scroll down to press OK. If you have my exact menu, then you need to go down to where it says line and keep pressing over until you find this one. So it's like the lower half plane triangle. So if you have a calculator like mine here, where there are no symbols to choose under the app, under the no app category, so if no symbols to choose, then you're going to select this when you want a less than or a less than or equal to, and you're going to select this, I didn't draw that very well, what looks like this for greater than or equal to. So right now we're doing less than, so we want to select this one. So that's what I have selected here. Then I scroll down to OK and press enter, and you can see that it's changed it now to look like that. If you have the very oldest model of calculator where when you press enter over top of this, all it does is just start changing it, it doesn't bring up a menu, then you just keep pressing enter until you get this one. So lower half plane shaded, it's like the bottom, kind of like our ramp going down. So you want to select that. So again, multiple ways depending on the model of calculator that you have. But once you have that, right now we had a standard window from the last section, and we should be able to work in a standard window here as well. So go ahead and press graph. And it'll think for a minute. And then, voila, it gives us our beautiful parabola as well as the shading. So when you change the symbol, it gives us the shading. Now, just like in last section, the requirements for your homework. You must list the ordered pairs of the vertex and any x-intercepts. So if it has x-intercepts, you need to find them. If there are no x-intercepts, you'll have to use the table to plot at least 1 point on each side of the vertex. You don't have to list those ones, but you do need to actually plot them on your graph. So you're going to list ordered pairs for vertex and any x-intercepts. If there aren't any, you'll use the table to get some extra points instead of x-intercepts. And then you will graph by hand remember to dash for greater than or plain less than, and don't forget your shading. So here, again, we're going to use our calculator to help us find the actual points, and then we're going to graph them by hand on our paper. So here, I'm going to find the vertex, so second trace. This time it's a maximum, so choice 4. So same thing that I did in last section, so left bound, right bound, enter, and there you can see we've got 1.33333. So 1.33 is fine, we can round it. And then our y coordinate there is 8.3 repeating, so it's probably 8 1/3. So you can list the fraction if you know it's a fraction. If not, that's fine. You can list the decimal equivalents because you are allowed to use your calculator. So 1.33, 8.33 is our vertex. This one does have x-intercepts, so I need to find them. Second trace, choice 2. So again, it's all these same calculator features that we've gone over lots of times before. So left bound is right there, press enter. Right bound, press enter. Guess. So it's negative 1/3, 0. So my x-intercepts, I'm going to list the fraction this time because I'm sure that that one's at negative 1/3. Again, you can list the decimal if you want. Then find the other x-intercept, which is over here, second trace, choice 2. So left bound is right there. Right bound over here. Tell it to guess. And that one comes out evenly. It's at 3, 0. So there's our other x-intercept. So now I just need to plot it. So 1, 2, 3, 4, 5, 6, 7. I'm going to need to extend this. 8 because I need it to go up to 9. All right, so 1 1/3 and then up to 8 1/3. So there's where my vertex is. Then I have x-intercepts at negative 1/3, so that's right here, and positive 3, so right here. And so then connect them, again, remembering that this should be dashed because it was a plain less than. So now it's dashed. And then I'm going to shade it in. Again, it did that for me on the calculator. It's shaded on the inside. Again, if you wanted to do it by hand, you would just plug in the 0.00. It would give you a true statement, which would tell you the part inside with 00 should be shaded. And so this list and this graph is all you would need in the homework for 12-5. So it asks you, you'll be doing 4 of these graphs. Make sure you list the points if you want your stamp and if you want credit. All right, that is it.